Hi everyone. So we will start our discussion of numerical methods. The first method we want to discuss here is bisection method. In bisection method, we follow this pattern. We will illustrate with an example, then we will define what is percentage error and we will give some exercise problems, and after that we will discuss the general procedure. So let us start with an illustration problem. For what real number x, the function f of x cube minus x minus 1 becomes 0. So we will be using intermediate value theorem or a special case of intermediate value theorem. We will take a function, continuous function on closed interval a b, and f of a and f of b are of opposite sign, then there exists at least one real number xi between a and b such that f of psi will be equal to 0. Let us apply this theorem in this particular case. The function f of x here, which is x cube minus x minus 1, is a polynomial and is continuous. Now f of 0 is minus 1 and f of 2 is 5. So by the theorem we can say that there exists a 0 between 0 and 2. Now what we will do? As the name suggests, we will bisect the interval into two equal parts. That means we will find the midpoint of 0 and 2. Let us take x naught. We will denote the midpoint as x naught. 0 plus 2 by 2, which is 1. Then we will calculate f of x naught, which is f of 1. And then we will observe that f of 1 is minus 1 and f of 2 is 5. So they are of opposite sign. That means that there is a 0 of the function between 1 and 2. Now we will proceed as earlier. We will bisect the interval. That means we will find the midpoint of 1 and 2. That is x1 is 1.5. F of x1 is 0.875. F of 1 is already we calculated, it is minus 1. So f of 1 and f of 1.5 are of opposite sign. Then your 0 is between 1 and 1.5. Now we will take the midpoint of interval 1 and 1.5, which is 1.25. F of 1.25 is negative. F of 1.5 is positive. So there is a 0 between 1.25 and 1.5. Proceeding similarly, we will calculate the midpoint x3, which is 1.375, and we will observe that 1.25 and 1.375 are of opposite sign. So there is a 0 between 1.25 and 1.375. So we will take x4 as the midpoint of 1.25 and 1.375, interval 1.25 and 1.375, which is 1.3125, and f of x4, which is f of 1.3125, is negative and f of 1.375 is positive. So we get our 0 lies between the interval 1.3125 and 1.375. Again, x5, the midpoint of that interval, which is 1.34375, which is whose value f of 1.3125 is negative and f of 1.34375 is positive. So 0 is between 1.3125 and 1.34375. x6 is the midpoint and value at x6 is positive and value as f of 1.3125 is less than 0. So your 0 lies between these two intervals. Now there is a natural question that how many steps you should continue this one. If you get 0 in between, okay, you can stop there. If you are not getting 0, what you will do? So one method is you have to fix your interval length. I want my interval length should be this much small. So up to that you will go. Another method is more easier to work. We will define percentage error. Actually, you have to take epsilon r, and it will be xr prime minus xr by xr prime. It's absolute value only we will take, and xr prime is the new value of xr. Then we will computation, you will stop when epsilon r is less than or equal to given epsilon p. So let us go back to the previous problem and check how we are applying this one. So already we have calculated up to x6 starting from x0. Now we assume that our epsilon p is 0.02. By the previous formula, each step we will calculate error. So you can see that from the table at the sixth stage, when x6 is 1.328125, our epsilon r will be 0.011, which is less than our given epsilon p. So we will stop our process there, and we will say that our approximate value of the root is 1.328125. Now try this following problems. The first problem is a generalization of this one. Explain the procedure of the bisection method in a general case. Using that method, solve the question 2, 3, 4 and 5.